Hello, welcome to Unit 4, Day 4. Today we're going to be talking about two variable inequalities. So up to this point we've seen inequalities that have one variable, like x or something like that that's in it. Today we're going to be talking about two variable inequalities. They might have like an x and a y. Right? And we want to learn how to graph these things and understand where the solution set to a two variable inequality is. Right? So we want to understand what that solution set is and how to find it. All right, so we're going to start this off by looking at two different two variable inequalities. And you can tell these are two variables, right? Because we see a y and we see an x. And same thing over here, we have a y and an x. All right. Now, you'll know that these are inequalities simply because they have inequality symbols here in between the y and the other side, right? So you have these inequality symbols. Now, normally when we have seen these before, we've seen something like this, right? Normally it says y equals 2/3 x minus 3, right? This is normally what we're used to, but now instead of this equal sign, we're getting inequality symbols in between those two sides of the equation. All right, so we're going to talk about what that means, and we're going to learn how to graph. And I've got this step by step here for you so you can just remind yourself of what you're supposed to do and how to finish off the problem. All right, so when we read an inequality like this no longer says y equals 2/3 x minus 3. It says y is greater than. So what we're looking for is we're looking for all of the points. All right. So if we're thinking about a graph, we're looking for all of the points that have a y value greater than this expression when evaluated for x. And I know that doesn't make a whole lot of sense to you right now, but we're going to see what that means here in just a minute. All right, so to figure this out, we are going to graph this thing just like we would if it were a regular line, right? So we would graph it as though there were an equal sign in between the left and the right-hand side. All right, so to graph this, you might recall, right, this looks a lot like y equals mx plus b since we're graphing a line, right? That number in front of x is our slope, and the number on the end here is our y-intercept. Okay, so if I'm looking at my inequality here, the slope is going to be 2/3, and the y-intercept is going to be 0, -3. Okay. So I can use that information to construct my graph. All right, so we're going to go down here. I'm going to start by plotting this point 0, -3. So I'm going to go 0, down 3, and I'm going to plot a point. And then my slope tells me where to go, right? So starting at this point that I just plotted, the slope tells me to go up 2 and over 3. So remember, this is rise. And this thing here, this is run. Okay, so this is telling me to go up 2, right 3. So I'm going to go up 2, right 3. Plot a point. All right, so it gives me a second point. Now all I have to do is draw a line. All I have to do is draw a line through those 2 points. I'm going to do that next. Let's see if I can get this lined up nicely here. So I'm going to get that going. There we go. There we go. All right, so there is our line, right? So we did part 1, it says graph the inequality just like you would a line. All right, so now I have my line, and then I'm going to test a point. And let me show you what that means. So as it turns out with these inequalities, if we want to figure out where all of the solutions are, so we want all of the points, not just a single point, but all of the points where y is greater than the expression evaluated for x, it turns out that all of those points are either going to be on one side of the line or the other side of the line, right? So either above the line or below the line. Right, and to figure out which side of the line contains all of our solutions, we pick a point to test. All right, so I'm going to pick a point on this side of the line, right? So this is our line. I'm going to go to this side and I'm going to test a point. All right, let's say we test the point 1, 1. 1, 1 is on this side of the line, and I'm going to come over here. Remember, our inequality was y is greater than, and I'll keep that right here, right? Y is greater than 2/3 x minus 3. Okay, and I'm going to take this point 1, 1, and I'm going to plug this in for x and y, right? So I'm going to go to my x, I'm going to plug in a 1, I'm going to go to y, and I'm going to plug in a 1. All right, so y gets replaced with a 1, we still have 2/3 times x, but x is getting replaced with a 1 as well, minus 3. Okay, so we're going to say 1 is greater than, and I'm going to grab my calculator to help me evaluate this. Right, because I want to do 2/3 times 1, which we should know, right? 2/3 times 1 is just 2/3. All right, and then we're going to subtract 3. So I'm going to say minus 3. There we go. So we got negative 2.33. So now the question is this true? Is this a true statement? Is 1 greater than negative 2.33? And in fact it is. This is true. Okay, so this point is a solution, which means every other point on this side of the line is also going to be a solution. So what we do with inequalities is we shade every single point on this side of the line, right? So I'd go over here and I would shade everything on this side of the line. So every point over here is going to do the same thing. It's going to create a true statement. If I pick a point over here, let's see what happens when I pick a point on the other side. Okay, so let's say I pick the point, I don't know, 3, negative 3. Oops, let me grab my pen again. So let's say I pick the point 3, negative 3. So this point right here. That's on the other side of the line. Watch what happens with this one. Okay, let's start over. So if this point is 3, negative 3, that means x is going to be 3, y is going to be negative 3. So y gets replaced with negative 3 greater than, and then we do 2/3 times 3, right? Because the x gets replaced with 3, and then we have minus 3. All right, so I'm going to grab my calculator, and I'm going to evaluate this right-hand side, right? So I'm going to do 2 divided by 3. That's my slope. I'm going to multiply that by 3. Gives me 2, and then I got to subtract 3. And we get negative 1, right? So we end up with this statement. Negative 3 is greater than negative 1. Well, that's false. Negative 3 is not greater than negative 1. It's smaller than negative 1, right? So this is false, right? Which is what we had suspected, right? So I tested a point on this side. It was true. So I shaded that side, meaning that every point on this side will make a true statement, and every point on this side of the line is going to make a false statement. All right. So let's go back real quick. We got one more thing that we need to discuss with this graph, but we're going to come back to it after we do this graph. Okay. So let's take a look at this one. Now, this one's very similar to this one over here. You might notice the right-hand side of the equation is the exact same. The only thing that changed was the inequality symbol, right? I made it go the other direction, and I added an equal to bar. Okay, so we're going to see what the difference is between this inequality and this inequality is. All right, but graphing it is the same exact process. The slope is still 2/3, and the y-intercept is still negative 3. Right, so I'd go to negative 3. I would go up 2 over 3, just like I did in the last line, and then I would draw a line through those 2 points. There we go. So there's my line. And we're going to test a point just like I did over here. I got to test a point and see which side is going to be true. Now, you might be thinking, when it was greater than, we shaded this side of the line. The inequality symbol did flip here, so now it says less than. What do you think is going to happen with what side we shade? All right, so let's test the same 2 points. Okay, so I'm going to test 1, 1, just like we did last time. And I'm also going to test 3, negative 3. I'm going to do both of those. So I want to test the point on each side. So I'm going to come over here and I'm going to say y is less than or equal to 2/3 x minus 3. And then I'm going to plug in my x and my y value, right? So x and y are both going to be 1. So y gets replaced with a 1. X gets replaced with a 1. And we evaluate. And it's actually going to be the same thing that we got over here. We got 1 less than or equal to. And I believe we got, last time we did this, negative 2.33. Right, so this is what we got when we did this, and you have to ask yourself, is this a true statement? Right, so the difference now is that this says less than. Is 1 less than negative 2.33? Well, no, that's false. 1 is bigger than negative 2.33. So all the points on this side are going to create false statements, which means all of the points on this side are going to create the true statements. Okay? I don't even need to test this. Once I know what one side does, I automatically know what the other one does. So if this side is going to be false, then this side must be the true side. Okay, so all of the points over here on this side of the line will be true. Okay, so you see the effect that that inequality symbol had. All we did was flip its direction, and it changed the side that we shade. Now we got to figure out, what does this equal to bar do? All right, and as it turns out, what that equal bar tells us is whether or not we can actually pick a point on the line itself and get a true statement, right? So for instance, if I picked, if I were to pick a point that was directly on the line, such as, let's pick this one. Okay, we'll pick 3, -1, and see what happens. Okay, so I'm going to come over here, grab my pen, got it. I'm going to set up my inequality here. So we got y equals 2/3 x. Remember, for this point right here, we're doing 3, -1. So that means y is going to get replaced with a -1, less than or equal to, and then we have 2/3 times 3 minus 3. Okay, and we would go and calculate that. So let me grab my calculator here. So we got -1. Oops, not -1. We got 2 divided by 3. That's our slope. Times 3 minus 3. And we got -1. So we got -1 less than or equal to -1. Is this a true statement? And it is. It is a true statement, right? Because it says we can be equal to. -1 is allowed to be equal to -1, right? So this is a true statement. So the points on the line, all of the points on the line here, are going to end up making that inequality be true. Okay, let's watch what happens over here. Okay, so I'll start this over just to give myself some room. I'm going to pick that same point. Right? I'm going to pick that same point. I'm going to pick 3, -1. Okay, so that means y gets replaced with a -1, greater than, and then we got 2/3 x minus 3, but the x is going to get replaced with a 3. There we go, because the point was 3, -1, right? So here we go. I'm going to evaluate just like I did over here. So we know we're going to get -1 again, and then we ask ourselves, is this a true statement? So -1 greater than -1. Is -1 greater than -1? Well, no, it's not. It's equal to it, but it's not greater to it. So this is false. And what this tells me is that the points on the line are not solutions. Okay, so the way that we fix that, the way that we show the person who's reading our graph whether or not the points on the line are solutions, is we dash the line. Okay, so we do this. So I'm just kind of taking an eraser and I'm making it a dashed line. Okay, just like that. All right, so you see how it's dashed now? This one is dashed because this did not have an equal to bar. This one remains solid because it did have an equal to bar. All right. All right, so let's finish off some of these questions here. So it's asking, is 2, 3 a solution? So we're looking at 2 and then 3. So that they're just giving us a point. They're wanting to know if that is a solution. And it's actually really easy once you have a graph, because you can go right to, let's get rid of this point that we were working with before. So we have a clear graph. Right, and graph this. Here we go. So we're going to go right to up 3. So here's a point, and that is in our shaded region. So is the point 2, 3 a solution? Well, yes, it is. All right. Now, if we go over here and do the same thing, right? So for our graph here, it wants to know, is 2, 3 a solution? Well, if I go right to up 3, that point is not in our shaded region, so this would not be a solution. Okay. We'll do another one. So we did 3, -1 already when we did this over here. So we found that the 0.31 was not a solution for this one because we did not have an equal to bar, but over here it was because we did have the equal to bar. All right, guys, that's it for today's lesson. Hopefully that helps out. Just to recap, all right, one more time here, just to recap, we have to graph, test, and shade. All right, so you graph the line just like you normally would, pick some points and test them to figure out which side of the line you're going to shade, and then make sure you take care of whether or not the line should be dashed or solid. All right, remember, it's going to be dashed if there's no equal to bar. It's going to be solid if there is an equal to bar. All right, guys, good luck on the practice problems.